Hey guys, today we will discuss about intermediate value theorem. So let's see. Intermediate value theorem. So first we have to know what is the statement of this theorem. Let's see. ABB closed and bounded interval and here a function f will be continuous in this interval. Now if fa not equal to fb, then fx must assume wants all values between fa and fb in the open interval. Let's write first. This is the statement. ab is a given interval and f is a function which is continuous in this interval. Where fa not equal to fb, then fx must assume wants all values between fa and fb in the open interval ab. Okay. So first discuss how to prove this theorem. Here given that fa not equal to fb, then we will get one point between fa and fb. Let the point is mu, which is fa. Now we have to consider a function such as gx equal to fx minus mu. Now here fx is continuous and mu is a constant function. So mu is always continuous function. So gx is also continuous. Therefore gx is continuous. Now for the point x is equal to a and x is equal to b, what will we get? fa minus mu is equal to ga and gb is equal to fb minus mu. Now let's come to this point. Here fa minus mu, then it will be less than 0 and fb minus mu will be greater than 0. So here for the point a and b, the function g differs in sign. So we have to apply Bolzano's theorem. So by Bolzano's theorem we get that if fa and fb are of opposite sign, then we will get a point C in the interval, open interval AB, such that f of C, or here g of C is equal to 0. So here g of C gives us fc minus mu is equal to 0. Therefore f of C is equal to mu. C belongs to open interval AB. So for this point C, we get the value of fx is equal to mu. That was the statement that fx must assume wants all values between fa and fb in the open interval AB, and this is C. So the theorem is proved. Now we have to write this theorem. So let's start. Here first fa not equal to fb, so we have to write this here fa not equal to fb, and we assumed a number mu between fa and fb, so let's write this mu be any number fa that is fa less mu less fb. Now we consider this function gx. Now consider the function gx is equal to fx minus mu. So gx is interval AB. Then we put the values x is equal to a and x is equal to b. Now fa minus mu and gb is equal to ab minus mu. It was less than 0 and it was greater than 0. Here g a g b are of opposite sign, then we have to apply Bolzano's theorem. If you haven't any idea about Bolzano's theorem, then please check out the I button. Z of C is equal to 0. Obviously, this is the statement of Bolzano's theorem. Then G of C is equal to f of C minus 0 is equal to 0. Implies that f of C is equal to mu. C belongs to open interval AB. Always we have to write this. Okay. Hence the theorem. Done. And the converse of this theorem is not true. Now let's take an example with the help of intermediate value theorem. Okay. This is the question. So that if x is equal to x minus cos x are at least 1, 0. So let's try to solve this. Here fx is equal to x minus cos x. This function is continuous, obviously, because this is polynomial and this is trigonometric. So fx is continuous. minus infinity to infinity. Now we have to consider an interval where two values of fx will be of opposite sign. So now let us assume an interval, closed interval AB, such that FA and FB are of opposite sign. So if they are of opposite sign, then there exists at least one point where f of x is equal to 0. Real number C belongs to open interval AB that satisfies f of c is equal to 0. Now in this interval minus infinity to infinity, we take 2 points. One is 0 and other one is pi by 2. Now here f of 0 is equal to 0 minus cos of 0. Then what will be the value? Minus 1, that is less than 0. Again f of pi by 2. Pi by 2 minus cos pi by 2 is equal to pi by 2, greater than 0. Now we will apply intermediate value theorem. So using intermediate value theorem, what was that? Fx must assume once all values between fa and fb in the open interval ab. So here we can see between 0 and pi by 2, in this interval 0 and pi by 2, there must be at least one point where fx is equal to 0. So we can see that there must be a real number in 0 to pi by 2 that satisfies f of c is equal to 0. Therefore fx is equal to x minus cos x has at least one 0. Okay, so it's all about intermediate value theorem and its application. So I end this lecture here. If this video is helpful, then please hit the like button and share this video with your friends. So goodbye.